Hello everyone, welcome to this class on survival modules. Last time we discussed about actual modeling, so today we'll look at survival module and how we have and what we're supposed to know. So we can model mortality by assuming that the future lifetime. So the future lifetime here is we just talk about t. So the future lifetime is a continuous random variable taking values between what? Between 0 and some, limiting age, say omega. So from this starting point, we can calculate the probabilities of survival and the probabilities of death for an individual aged X over a period of T years. So what are we talking about here? So in survival modules, there are some assumptions that we should consider. So the first assumption, is that what? The future lifetime of a newborn person is a random variable. The future lifetime of a newborn person is a random variable denoted by t, which is continuous. So this random variable is continuously distributed over an interval, say omega, 0, omega. So now we need to define this distribution function. So what do we talk about? So the distribution function is just ft, which is equal to what? The probability that t is less or equal to small capital T. So this is a distribution function of t. So here t is what? It's just the future lifetime of this newborn baby in the interval 0, omega. And the survival function. So the survival function is done by st, which is just the same as probability that the future time is greater than the small t. So this is the survival function of t. The survival function of t. So here from the survival function of t, we have the probabilities of death and survival. So you need to know about probabilities of death and survival. So what are we talking about here? So the probabilities of, first we start with the probabilities of death. So from the probabilities of death, we just look at this t qx is equal to f of x. T and survival is tpx is equal to 1 minus t qx, which is just the same as sxt. So these are the two probabilities of death and survival. So here in this case, what is the combination and what is the combined name of t and p? I mean tqx and tpx, what are they called? So here tqx and just qx, these are called what? These are called rates of mortality. So there's a difference between tqx and just qx. In the qx, t is equal to 1, and so we look at force of mortality. When we talk about the force of mortality, this is just the force of mortality is just the quantity that plays a central role in the survival module. So this force of mortality is denoted by nu x is equal to limit as h approaches 0 plus 1 over h by p. Then we have what? T less or equal to x plus h given t greater than x. So this is further simplified to say if we have f of x small h, this is just approximately equal to hqx. So for small hqx, this is just approximately equal to capital H nu x, where nu x is the force of mortality. So now we look at how we can define force of mortality. So what do we say? So here, proper definition. So force of mortality for x greater or equal to 0 and t, which is the time, greater than 0, we could define the force of mortality. What is force of mortality? So we have x and t, so you can say nu x plus t as, so the first definition is, sorry about that, so the first definition is nu x plus t, which is the same as the limit h approaches 0 plus 1 over h by what? By the probability that t is greater or equal to x plus 8 plus t plus h given t is greater than x plus t. Then the second definition, we say nu x plus t is just equal to the limit h approaches 0 plus 1 over h by the probability tx. This time we don't just have t, we have tx less or equal to x is equal to t plus h given tx is greater than t. So these are the two definitions of the force of mortality. So now we look at survival probabilities. So under survival probabilities, we're going to look at how we can see the relationship between st and st over sx probabilities. So under the survival probabilities, so survival probabilities, as we discussed earlier, is denoted by xt, which is just what? Probability that what? Tx is greater than t. So this further simplifies to say what? Just the probability t is greater than x plus t given t greater than x. So this is the conditional. Using conditions properties in statistics, we have probability that what? Tx is greater than t plus x plus t over p t greater than x. So the top part is what? The top part is just x plus t, and the bottom part is just what? X. So this is some result which will relate to what we're going to see in the further steps of discussion. So we have s plus t. We have s plus t. Then what? This is the px is equal to spx by t px plus s. Or we have s plus t px is equal to tpx by spx plus t. So these are two important results. We'll see later on how we apply them. We also have another important result. So these we need to know, and we need to know how to apply them in certain questions. We also have for the survival probability, we have f of x t, which is just the same as what? T px nu x plus t. So this nu x plus t, as we saw earlier, is what? Just the force of mortality. and this TPX is just a survival. So from if we have a survival and the mortality, this leads us to the probability distribution function, which is just the PDF. So this is the PDF of T. So we look at now the live tables. Live table functions. So the live table functions. So under the live table functions, we have what? We have some notations that we're supposed to know. From the notes, the notations are, we have dx, which is just the depth, which is Lx minus Lx plus 1. And we have what? Px is just equal to Lx plus 1 over Lx. So this is Px, just a survival, and Qx is the depth, which is what? 1 minus Px, which is equal to what? If you further simplify, if you put Px, what is, if you replace Px in Qx and further simplify, we have Lx minus Lx plus 1 over Lx, which is just the same as saying this is dx over Lx, because the top part is just dx from the first one here. Yeah. So in this case, our t in this Qx is just 1. So if we further just have a general formula for survival, then we can just say T Px is equal to Lx plus T this time, not 1, over Lx. So this is the live table function for the survival. For the survival function. So we move on. Now we look at the Bauducci assumptions. The Bauducci assumptions. The Bauducci assumptions. So these assumptions are also important if we're looking at integer edges of x and 0 less or equal to t less or equal to 1. So under the Bauducci assumptions, we have 1 minus t. This is Qx plus t is equal to 1 minus t Qx. And this is valid for all integer edges. For all integer edges x and in the time frame 0 is equal to t is equal to 1. So how do we see now? From we can have an example. You can say, for example, e.g. So we have in our example we have age x and the live table function Lx. So here we have 58 and we have 88,792. The next one is what? 59. We have 87,805. So in our example, what are we supposed to find? So in our example, we need to find what? We need to find L58.25. So solution. So now we need to find L58.25. So L58.25 is in between 58 and 59. So how do we get that? So we need to subtract, need to know the difference. How many deaths are there in between 58 and 59? So this is 88,729 minus 87 805, which we get from 924. 924, is it 924? Sorry about that. This is supposed to be 9 yes, so this was supposed to be 87 88 792. So this gives us 987. Yeah, that's correct. So in this case we have assumption that what the deaths are uniformly distributed. UD is uniformly distributed, and we have 0.25. 0.25 is just the same as 1/4. If this is a decimal place, so we have 987 over 0.25. 0.25 is just 1/4, so 987 over 4, which is what we have 246.75. 246.75. So now we need to find L58.25. So how do we get L58.25? So L58.25 should be above 58 but below 59. So we say L58.25, which is equal to what? 8872 8892 minus 246.75. So we get what? We get 88,545.25. So this is how we find L58.25. So the uniformly distribution, we now look at the uniform distribution of deaths. Uniform distribution of deaths. So under here we have what? So we're looking at deaths. So what's the death function? We have TQX, which is equal to what? Which is just the same as TQX. So here QX is just the internal rate of mortality, because it is the probability that alive at the exact age X, this X here, dies before X plus 1. Dies before X plus 1. And we also need to know about MX. So MX is just what? So MX is just the probability of dying between exact ages X and X plus 1 per person per year between exact ages X and X plus 1. So MX is given by, we have the integral 0 to 1, we have the survival TPX, we have the mortality nu x plus t dx, and this is over the integral 0 to 1, we have TPX dt. So MX is just what? In this case, MX is just the weighted average of the force of mortality. So this is just the weighted average of the force of mortality. So if you're asked to find the weighted average of the force of mortality, that means we're just simply asking you to find MX. Then you can just apply the formula that's given. So we look at expected future lifetime expected future lifetime. This is what? This is denoted by E TX expectation. So this what is this expected future lifetime? This is just the expected future lifetime after age X. That is the expectation of a life at age X. So it is denoted by E not X. We have a small letter on top. This is just expected, and it is found in the actual tables on. So we can find these values on page 167 and so on. So for example, so how we can see an example on this. So we can say turn to ELT15 males. So you need to have a periodic you need to have a formula book and find the complete expectation. You need to find the complete expectation of life E naught X for. So the first one, newborn baby B, a 21-year-old actual student. C is what? C, we need to find the complete expectation of a 70-year-old pension. So for the first one, you go to the periodic table and you turn to ELT51. So from there is a column, then you can see E naught X. So for the first one, a newborn baby, so in our case a newborn baby X is equal to 0. Then from the tables, X is equal to 0 is corresponding to E naught 0, which is equal to what? E naught 0, which is equal to 73.413. And for the second one, X is equal to what? 21. So E naught 21, which is just the complete, which gives us 53.497. And C, for C we have what? X is equal to a 70-year-old pensioner. So E naught 70 is equal to 11.187. So these are very, very easy. Using the formula book, we can easily find what we need to know. So we are done with the complete expectation of life, which is denoted by E naught X. So now we look at the accurate expectation of life. Take the expectation of life. So under this, to define this, we need to define what? We need to define Kx. We need to define Kx, which is what? The quotate future lifetime of age X. So Kx is just what? The quotate future lifetime. Kx is a quotate future lifetime. So Kx is equal to what? It's just Tx. So if we apply probability on this, we say P Kx is equal to K, which is equal to what? Probability that the quotate future lifetime aged X, so which is K, is equal to Tx less than K plus 1. So this is further simplifies and gives us and gives us this interval k less than tx is equal to k plus 1, which is just same as k px dot qx plus k. So now I can introduce the concept of differing. So when you say differing, how do we denote this differing? So differing is denoted by k deferred qx, which is just as much probability that kx in this case is the quoted future lifetime is equal to just k. So differing means deferring the event of death until the year that begins in k years from now. So differing is just pushing things ahead. So now the quoted expectation is denoted by ex only. So ex is just the expectation of the quoted future lifetime, which is what kx. So you need to know the difference between the quoted expectation and the complete expectation. So how do you find the quoted expectation on the tables? So from the tables, you can have another example, e.g. So say look up the AM 92 mortality table and find the quoted expectation and the quoted expectation of life ex4. So for the first part we have what, a 21-year-old AS student, actual student, B same 70-year-old pension. So from this example you have to do the same as we did in the previous example of the complete expectation. So here I'll just show you how to do it and you can look it up. So you need to go to AM92 of mortality and find the quoted expectation. So here we're looking at AM92. So in your tables you need to go to that page only. So for A we have what, E21, and B we have E70. So here we're just looking at E21 and E70. So you can easily, from that you can easily get the values. Let's look at the relationship between what's the relationship between what, E not X, which is a complete, and EX. So this is very important. We will look at it. We need to know how to apply this relationship in our calculations. So this relationship, we just say E naught X is equal to what? Approximately equal to EX plus half. EX plus half. So how do we apply this? Let's say we have an example, e.g. So here we're using ELT15 for males mortality. So here what are we supposed to find? When we want to find the quoted expectation of a life of EX4, so we need to find the quoted expectation. So these are just simple things. Just play with the formula of what, of life EX4. So A we have what, a newborn baby, and B we have what, a 21-year-old S just student, and C as 70-year old pension. So for A, we need to find the QTECT expectation EX. So how do we find this? So using this relationship, we have E naught X is equal to, is approximately equal to EX plus 1/2. So for A, we need to find what EX. So how do you find EX? You just make EX a subject of the formula. So EX is equal to E naught X minus 1/2. So for a newborn baby now, E0 is approximately equal to E naught X minus 1/2. So from here, you can go to the males and check the values for E naught X, for E naught X, yeah. So once you put it, E naught X from our tables was what was our E naught, you can check from the table what yes, so E naught X was 73.413 minus 1/2. Then if you calculate this, you get E0. So you can find that. So you do the same for B and C. So you do the same for B and C. So now we'll look at important formulas that we need to know. So important formulas. So these formulas are very important because we will be applying them in questions, and we need to find what the question is asking about. So depending on the question, a specific formula is supposed to be applied to. So from our discussion, so we look at the first one. So the first one is what? First one is just TQX. TQX is just a survival, which is it's just a death probability. So this is just equal to integral 0 to T fx s ds. So this further simplifies to integral 0 to T spx, then the force x plus s ds. So this is TQX. This is one of the important formulas. This is one of the important formulas that you're supposed to know. So in this formula, SPX is what? Is the probability of surviving, to age x plus s. Then the second part in the formula, so I've defined this, and what is nu x plus s ds is approximately just ds qx plus s. This is just the probability of dying just after age x plus s. Then the second important formula, so the second important formula is T px is equal to expectation negative integral 0 to T nu x plus s ds. This is the second important formula that we need to know. These are two very important formulas. So you need to also know about the derivation of TPX. So should I? Okay, let's try to anyway. So you need to know about the derivation. If you have any problems on the derivation, please feel free to let me know and I'll explain it further. So we move to simple parametric survival modules. We have simple parametric survival. Simple parametric survival. So from our previous from the previous work we've done so far, we know that TPX is equal to SX which is just what? Which is just the expectation that the integral 0 to t mu ds. So which is, if you integrate this new ds, we have expectation of what? Nu t. From 0 to t, if you integrate that further, you get that. So that's the TPX that we are supposed to use in parametric survival modules. So the random variable denoting the future lifetime has a distribution function expressed in a small number of parameters. So if you have a small number of parameters in a question, then simply apply the parametric survival modules formula. So we have a question which is 7.12. So you can check this question in your formula, in your notes. So the question says, if nu x takes a constant value of 0.001 between ages 25 and 35, calculate the probability that a life aged exactly 25 will survive to age 35. So in our question, nu x takes a constant value of 0.001. So our question is saying nu x is equal to 0.001. Ages between 25 to 35. So what's the question saying? Age time frame is what? 35 minus 25, which is 10. And our x in this case is from age 25 exactly age 25. That's our x will survive to 35. So if we're talking about surviving, so we need to apply the survival formula. So the survival formula is TPX is equal to expectation negative integral 0 to t nu x plus s ds dt. Sorry. So we just put what we're supposed to in the formula. T is what? 10. So this is 10 p 25 is equal to expectation negative integral 0. Our time is 10 and mortality is 0.01 dt. So from here it's just simple calculus integration. So this is, if you integrate that, you get expectation negative 0.001 t. What are the limits? 0 to 10. If you first simplify that, you get e negative 0.01, which is just the same as 0.99005. So this is how you apply that formula. Then we have another question, 7.13 from the notes. So this question says if new x takes a constant value of 0.025 at all edges. So this different. This question is different. It's now saying at all edges. Calculate the edge x for which xp0 is equal to 0.5. So here they are saying at all edges. So now we have to use a simple parametric approach. So we have tpx is equal to expectation. The second part is new t. Here from the question, xp0 is equal to 0.5. So if we put that in the formula, in this formula we have 0.5 is equal to expectation. What's our new? Our new is what? 0.025. And what's our t in this case is x. So you put x here. So you need to solve for x now. So how do you solve for x? You introduce logs, natural log. In this case, we are supposed to only use natural logs. So we introduce natural log. So we have in 0.5 is equal to minus 0.025x. This is just simple arithmetic. Make x a subject of a formula. We have in 0.5 over negative 0.025. So using our calculators, we get 27.726. Yeah, so this is how we do it. Then we look at Gomez and Markingham's law. So we have Gomez and Markingham laws. Gomez and Markingham. So we look at Gomez and Markingham. So the definition of Gomez. So Gomez law just is just an exponential and is reasonable for mid and order edges. The condition for this one is just middle and odd edges. So Gomez law is new x is equal to bc to the power x. This is just an exponential. And Markingham's law. From Markingham's law, we have what? So under Markingham's law, it's just allowance of accidents. Allowance for accidents. Allowance for accidental deaths, depending on age, and it's denoted by new x is equal to a plus bcx. So you need to know these two. You need to know these two laws for Markingham's and Gomez because we use them in calculating. So in the assignments we had questions regarding these two laws, and we saw how we need nobody faced any problems in calculating the constants b and c. But on the survival probabilities, so under survival probabilities, if we incorporate these two laws, so we saw that the formula for survival probability was tpx is equal to just the expectation of negative integral 0 to t new x plus s ds. So this is survival probability. Now under Gompe's law, so under Gompe's law, if a question says find the survival probability under Gompe's law, so what are you supposed to how are we supposed to tackle this? So you need to use this formula. TPX is equal to G, then CX, then CT minus 1. So where G is just the same as exponential of what? Minus B over natural log in C. So in the notes, it says log C, but when using the calculations, always use in C, which is the natural log, so that you can get the correct answer. Okay, because in the if you use the logarithmic, you get a different answer. So always use this natural log. And then under Markingham's law, so what is the first survival probability? So we have you need to use this formula. TPX is equal to STGC x to the power x CT minus 1. And G here is just the same as expectation minus B over in C. And S is equal to expectation of A. So this is how you do it. And then we look at the last part now. So we are done with Markingham and Gompe's law. So to close up this chapter, we just look at one question. So we say question. So in a certain population, the force of mortality is given by, so we have this range 60 less than x less than or equal to 70. New x is what? 0.01, and 70 less than x less or equal to 80, we have 0.015, and x is greater than 80, we have what? 0.025. So we need to calculate the probability that a life aged exactly 65 will die between exact ages 80 and 83. So we say calculate. We need to calculate the probability that what? Yeah, life aged exactly 65 will die between exact ages 80 and 83. So this is a very interesting question. It's talking about the differing part. So what is the question saying? So 65, so our x in this case is 65. So from 65 we need to find between what? 80 and 83. So we have Q 65, then 80. How do you go to 80? So 80 is 65 plus 15. So this is 15 and 3 here. This 3 is the range from 80 to 83. So what are they talking about here now? Here they're just saying we need to find the probability I mean, in the survival case, we have this time frame. So we have SPX, this is X, and T plus X plus S. Okay. So what is this saying now? Calculate the probability that a life exactly age 65 will die between 80 and 83. So for that part, we have this one, this timeline. We will die between 80 and 83. So TQX plus S represents 80 and 83. But this person is still alive, so we say SPX. Yeah, this makes sense now. So this is just the multiplication. So under this formula, from this explanation, you can say 15 divided Q3 Q65 is equal to, is surviving, is at 65. So P15 65 by 3Q80. Are we together? S is 15. How did you get 80 here? So let me just show you. So this is 15 divided 3Q65 is equal to TPS. S is what? S is 15. 15P. X is what? X is here in this case, X is 65 by, what's our T? Our time frame is 3Q. What's our X? 65 plus 15. This gives us 80. Yeah, so we get 80 there. So P1565. So from P1565 we have 5P65 by 10P70 by 1 minus 3P80. So from this step, the first one, why are we using why are we getting 5P65? 5P65. So 65 is the starting. We need to calculate the probability that a life aged exactly 65 will die between 80 and 83. So 65 is between 60 and 70. And our new X is what? 0.01. So 60 and 70, but we're starting at 65. So that's why I'm saying 65, and the time is 5. From 65 to 70, that's 70 minus 65, that's 5. That's the time. So for the first one, we have E. If you use the formula 5, which is the time, and the force of mortality is 0.01. Then for the second one, we're from 70 to 80. So our T is what? 10. Okay. And 70 to 80, and our X is 70. So we have E negative 10. Loss of force of mortality is 0.015. So we have 0.015. Then times 1 minus E 3, 0.025. So where is this 3 coming from? The 3 is coming from here, 80 and 83. So this is 80 and 83, somewhere here, 83 and above. So our force of mortality is 0.025. So if you use your calculator, you get 0.0592. So we come to our end of our lecture. Thank you.